Hi, my name is Himanshu and I'll be taking the Machine Learning and Data Science course in this video lecture series. So before starting the course, I would like to take a moment and discuss something related to the proceedings of the course. So the course is actually divided into 10 modules, each module designed in a way that it will help you proceed to the next module in a procedural and systematic way. After each module, you'll acquire a particular skill or some skills that would help you to progress through the course and to the next module. So to keep the course interactive, I would like for you to put down any questions or any doubt that you might have related to that particular module or anything in general, and I'll try to answer them as we go through the course. So what I'll be doing is, after every two modules that we cover, we'll have a video that will be on the doubts and the questions that we'll be posting in the comments in all these videos. So for every module there are sub modules, and for every sub module we'll have a video in which we discuss all about that particular sub module. So without any further ado, let's directly jump into the course. So the first part is perspective of the course. See, I want to discuss with you what the course actually is in perspective of. So the course will be going through the following topics. I'll be discussing all these topics right now. Each of them are divided into modules. There are a total of 10 modules which require you to have some basic knowledge of coding in any language. So for this course we'll be programming in Python. So the very first module that we have is Python Basics and Introduction to Python, in which we'll learn how to set up the environment, some theory related to Python programming, objects in Python, exception handling, and libraries, how to import libraries and how to work with libraries. So these things we'll be discussing in the first module. If you have prior knowledge of C or C++, that's good, because we'll be using objects and the concept of actually objects in Python are known as instances, but for relativity let's call them objects as of now. So objects and classes will be using them fairly. So if you have some knowledge regarding objects and classes, it's good, but if you don't worry, we'll cover it out as we go in this course. And some knowledge related to high school mathematics like linear algebra, elementary statistics, and differential calculus. All these might be sounding quite big of the terms, but they're not that hard of the topics as some of us might feel. But this elementary knowledge would help you to progress through machine learning and data science. But even if you don't have knowledge regarding this, don't worry, I'll try to give you fair intuition as we go along the course, so that you don't feel left out not knowing any of these things. They're fairly simple, so won't take much time to cover or to cope up with them. So yeah, as I said, we will be covering most of these things as we go along the course. So why is this course machine learning and data science? Why not just machine learning? So what happened was, when I was learning all these things, I didn't have the systematic mean to learn all these things, and hence a lot of the things got muffled up, and I had quite a trouble learning all these things. So that's why I've broken down the course in a systematic way, and I've started with data science and then we proceed to machine learning, because data science is as much an infrastructural part of machine learning as mathematics is, or as programming or Python or any framework is. So that's why we'll be starting with data science and then we'll proceed to machine learning. So yeah, let's now discuss about the modules that we are going to cover. So the very first module I've already discussed, Python Basics and Introduction. In this module we'll be discussing regarding Python, and we'll be starting up by setting up the environment. The environment that we'll be working in is known as Anaconda environment. I'll show you how to set the environment up. So those of you who have already who already have experience in setting up Anaconda environment and working in Jupyter Notebooks or Spider IDE, all these things, they might skip, but I would still suggest you, even if you're a intermediate coder, I would still suggest you that you watch this portion, because there's something that I would really like to discuss with you regarding setting up the environment. Other than that, if you have prior knowledge of Python programming, objects and everything, fair enough, but if you don't, please take a look at all these topics as we discuss them, because they will be the root level infrastructure for the rest of the course. After that, we'll jump into some advanced Python that would be more focused on the machine learning part of it, as machine learning consists of us using a lot of libraries and everything to make our life easier. So we'll be demonstrating the use of libraries in Python like pandas, numpy, matplotlib, and seaborn to visualize the data and everything. If you have worked with these libraries before, I guess you know why these libraries are used rather than writing code from scratch for all the operation that we do using these libraries. And if you haven't, we'll demonstrate why these libraries are actually used. And other than that, we'll learn how to use some basic functions and other functions in these libraries. We'll discuss as we go along the course, and we need all of them. And the third module will be working with the data right away. So what happens is a lot of people don't actually work with data as much as they should and directly jump into machine learning model, creating the model and training and testing and everything. But that's not actually going to result in a good machine learning model, because the very first step of a machine learning model, to build a machine learning model, is that collect the data and then look at the data and draw insight and get a familiarity with it. Unless you become familiar with the data and know it inside out, you won't be able to make predictions or get good result out of it. So for that reason, what we'll be doing, we'll be learning some theory related to that classification of data. Then we'll directly jump into a tutorial in which I'll be showing you how to web scrape some financial data and build the web scraper from scratch, in which we'll be directly taking up the data from the website and storing it in a CSV file, which is comma separated values, it stands for. Then we'll be jumping into EDA, which is exploring the data, or as formally it's known, exploratory data analysis. So in this, we'll learn how to draw, how to get to know the data and become familiar with it. Then analyzing and cleaning the data. So data cleansing is very important, very important, because the accuracy of the model, or how the model will actually perform when we test it out, all depends on how the inputs are perceived by the model. So if the inputs are not clear for the model, then it would actually result in a bad prediction. And analyzing it would require us to know the data and how to clean in what ways should we clean the data. That portion is covered in analyzing the data. Then manipulating and rescaling. So every data is actually, even if the data is related, it can be of various scales. For example, the length and the breadth of a leaf can be related, but the temperature in which a tree is growing might not be of the same scale, because it's in temperature and it's in centimeters. For example, the length and breadth are in centimeters. So those are of different scales, and we need to actually manipulate them and rescale them onto a common scale, so that all those data become relevant, and then we can make better prediction out of it. After that comes dimensionality reduction of data, what this is, and how it actually helps us in performing better. We'll get to know about that. This topic is broadly discussed later when we go to PCN and introduction to TSNE, but we'll get a brief introduction to them while we discuss dimensionality reduction. After that, we directly jump into the concept of machine learning. So as much as you would want me to keep it practical, I would like to keep this particular module theoretical, because knowing the theory of the machine learning is way more important than actually going out and starting to building the model. Because if you don't know the mathematics behind it and how it actually is working, then you won't actually be able to get better result out of the models that you build, because every model acts differently, works differently. All you know is that a machine learning model takes the data and makes prediction based on it. That is not going to help. You would have to know each and every models separately and their functioning separately. So machine learning I would like to keep theoretical. A little bit will go into the tutorial portion, but most of it will be theoretical. So we'll be learning how machine learning model works, how we classify different machine learning models, what model fitting, overfitting and underfitting is, what is feature selection and extraction from the data that we actually provide machine learning, and how different data act differently when given to different type of models. Then we directly jump into the first machine learning model called as linear regression. I've just kept it linear regression, but don't worry, we'll be discussing linear, multiple, and some logistic regression and all these things as well. So the model, how it works, we'll be learning the mathematics behind it. Then we'll directly jump into building this model from scratch. So what I'll try to do is I'll first show you how to build all these models from scratch. After that, I'll show you how to use different libraries that are available out there to get better performance and to make your life easier, rather than every time building the models from scratch. We'll be just building the models from scratch so that you know how the mathematics actually is working behind the model that we will be discussing in the theory portion of it. So what gradient descent is, the mathematics behind it, maximum likelihood estimation, all these things will be covered in linear regression. After that, k nearest neighbor and naive bayes, these are basically mathematical and statistical based models. We'll be learning about their implementation, what are the problems related to it. Then naive bayes is a small model, that's why I have just put down both these models in the same module. It will be fairly small topic. One of the easiest, two of the easiest models actually in the whole of machine learning. So it won't take much of time to discuss both of them in a single module. After that, clustering, we'll be jumping into clustering algorithms, k-means clustering, hierarchical clustering, bottom-up hierarchical clustering, choosing the k value, all these things we'll be discussing. Then principal component analysis is a dimensionality reduction technique, and TSNE is one of the advanced dimensionality reduction techniques. So we'll be mostly focusing on PCA and a little bit on the TSNE. So we'll be learning theory and we'll be building up a model from scratch for these things as well. Then support vector machine, it's a fairly mathematical model, but we'll try to keep it as simple as possible, and we'll try to not build the model from scratch because it might get a little messy and it might get too mathematical for some people. So we'll try to keep it as abstract as possible in terms of the working behind it, but you'll get a fair intuition of how the model works and what it actually results in and when to use this model. And then we'll jump into the one of the most talked about topics related to machine learning, that is neural networks, which is the fad these days. So we'll be discussing what neural networks are, what the idea behind it is, what we want to interpret from a neural network, how is it different from machine learning, and its analogy related to the human brain, how human brain works. Then forward and backward propagation, weights and biases, all these topics we'll be discussing, hyperparameter and parameters. Then we'll be building a neural network model from scratch because it's a fairly simple model if just for the start we are doing this. So we'll be building what's called a vanilla neural network, which is a single layer neural network, and then we'll be modifying it so that we can add more layers to it and get better result as we go along. And we'll be learning how to make the model better and make some changes that to get better results. So I guess that covers all the topics, all the modules that we are going to discuss throughout the course. So what I've done is I've created this repository in my GitHub, and you can directly go and find the resources related to each module. I'll be putting down these resources in the modules. For example, for the very first module, as we are going to discuss related to Python, for that reason I've put down two books related to them, Python 3 the hard way and Python 3 object oriented programming. You don't have to by heart all these topics, you just have to keep them with you so that whenever required you can reference them as you go along. Then some of the things in this course that I'll be using, like this assignment, and it's not an assignment, it's a collection of some questions. So a lot of these things will that I'll be using are not actually created by me. They're curated by me from different sources, so I don't entirely make any claim over them. So yeah, I would give fair share to whatever resource and from wherever I collect them and put down here. So what I'll try to do is keep all these models, model building from scratch, mine, and some of these resources such as these questions and everything, curated from different sources, because they're fairly simple questions, and I don't want to make any repetitions in getting them up for you to access. So yeah, and of course those books are not written by me, so yeah, goes without saying that those are actually curated as well.